Hello everyone, my name is Marta Wiśniewska, I'm from Poland, I live in Warsaw, and I'm super excited to be a part of this conference. I'm a Google developer expert in Angular and web technologies, and also a huge fan of progressive web apps. And today I will tell you how you can supercharge the speed of your apps with progressive web app secrets. And even if you're not familiar with PWA, but you want to get some knowledge about web performance, the presentation will be useful for you as well. Oh yeah, we need to talk. A few words why I selected the topic. Well, I follow different content about progressive web apps, blog posts, different talks, and so on. And still I can see there's a lot of different approaches and opinions regarding this technology. I can hear a lot about benefits because of business side, because of user conversions, user experience. But I try to find something that will be interesting for you, for developers. And I found that the most useful, it will be speed. Because progressive web apps allows you to create fast apps. And today I want to tell you what exactly it means. Because it doesn't mean if you apply service worker, then you improve all your performance metrics. I will tell you what makes progressive web faster, and also what are design patterns and caching strategies that allows you to improve web performance. So let's take a look at the agenda. I will start with caching strategies and design patterns to boost progressive web apps performance. Then I will tell you about the combination of progressive web apps with WebAssembly. And at the end, I will tell you about my performance experiments that I did on 15 progressive web apps that are already in production. I will tell you about the most common issues and also tips how you can avoid them. So let's get it started. Let's start with caching strategies and design patterns to boost progressive web apps performance. Well, caching is the main source of making your app faster. And before we started talking about progressive web apps, we also had option to store data in browser cache. But what Service Worker offers is better control over how cached assets are managed. And Service Worker, this is the heart of progressive web apps. This is a proxy between client and server. It provides persistent medium that allows you to store your resources in controllable cache, network requests like other pages, scripts, images, assets, and so on. And from practical perspective, this is a JavaScript file that is registered in your browser when you open it for the first time. Service Worker may make your app faster, but also may not. And even if your Service Worker is active, you have pre-cached your all network requests, it doesn't guarantee faster page loading. It only means that all your data will be retrieved from cache, eliminating any potential time to first byte issues. And another really important aspect is that caching only matters on repeat visits. And you can achieve faster load time, but if you open at least once your app and you will repeat it, and after that you can see this effect of faster loading. Because even sometimes you can see that the first loading is even slower than usually, because Service Worker is also a JavaScript, additional JavaScript to handle by your browsers. So it means that it needs additional time to handle that. And app speed, this is more a factor of rendering time after all your responses are collected. And please remember about running audit tests before caching, because if your app is heavy, have a lot of JavaScript, big assets, and so on, then Service Worker won't help you. And you should remove unnecessary JavaScript, CSS, libraries, dependencies, and also optimize your assets and images. It will help you to get faster apps. Now I want to tell you a bit about caching strategies. And before I do that, I want to tell you about two factors. The first one, where does the data live in your app? Currently, you have two options to retrieve your data. You have option to retrieve it from cache and from the network. And based on those options, we have different caching strategies. The first one is that we only retrieve data from network. And it was used before we started talking and using progressive web apps. With Service Worker, we have option to only retrieve data from cache. But to be honest, it's not really popular because from practical perspective, we use mix, a combination of cache and network. And first case is that at the beginning we try to retrieve data from cache, and if it's possible, we use it. But if we can't, then we try to retrieve it from network. And from the opposite side, and this case is great if your priority is to have fresh data. So at the beginning, you try to get data from network, so you send request to the server and you wait for the response to get the data and to fill your app with this data. But if it's not able, then you try to retrieve it from cache. So your app's still working offline, but you at the beginning, of course, you try to get it from server. And the last option, so this is cache network race. It means that at the same time you try to retrieve data from cache and network, and you use one that is delivered faster. And the second factor, before you start designing progressive web apps, how do you render the app? Currently, you have two options. You can apply server-side rendering or create client-side render app. And for server-side rendering, your server will generate the full HTML as a response to navigation. For client-side rendering, more actions are handled in the client rather than on the server. So we have to handle data fetching, templating, routing on the client side. And based on those two kinds of apps, we have different caching. So for caching on server-side render apps, we will cache the static part, so it means that full generated HTMLs. And it's quite simple to use, but the main con is that you're not able to create effectively working offline apps because you can't handle more dynamic cases. For client-side render and for caching on this side, we'll cache core code, images, assets, and so on, but we also need some cases to handle more dynamic data. And in client-side rendering, in caching, we use cache API and index database. And the main rule is that the URL data go into cache API, but non-URL data go into database. And the question is, which architectural solution is the best for your app? And it's good to divide your app into two parts and wonder what parts of your app are static, what can you call them the app shell, so that are parts typically involved with navigation that then repeat on a few pages or on the most of your pages. And what are parts are content, are more dynamic, that rather change more in your app. And apply for these different parts, we can apply different caching and different solutions. And the best option is to use a combination of server-side rendering and client-side rendering. And in this option, we will cache the app shell and the content of the first page that we render to your users because we want to retrieve it as soon as possible. But we also want to apply caching on the client side for dynamic cases. So we will use it and retrieve from cache while your user will navigate in your app. The second option is a pure app shell model. In this case, we will use server-side rendering only for the app shell, for caching the app shell. But for dynamic data, we don't want to apply caching. We only use JavaScript and we only send requests to the server to retrieve fresh data, because typically in this case, there's no sense to apply caching because your content changes a lot. And the other option is to only use server-side rendering and cache everything that you can. So this is the app shell, but also the full content. And this solution is great for static pages because it allows you to create really fast apps. But there can be a problem with fresh content. But if your app is still the same, has the same content, it's a really good solution. And the last option, this is only client-side rendering and only caching on the client side. And in this case, it's quite simple to implement, easy to do. But the main con is that it's quite slow, especially if you compare it to the server-side rendering, because every caching on client side is just additional JavaScript to handle, and it won't be so fast like in server-side rendering caching. Now let's talk about the second topic, about the combination of progressive web apps and WebAssembly. And I found this solution when I was considering two hottest trends if you're talking about the future of web performance. This is WebAssembly and progressive web apps. And maybe the idea is a bit abstract for you at the beginning and your reaction is like that, but keep calm, I will explain you very soon. Well, progressive web assembly apps are a combination of progressive web apps and WebAssembly. And I tell you a bit why we want to use progressive web apps because of web performance, but why we want to add WebAssembly. Well, currently JavaScript is the only one option to write front-end apps. It's really useful, universal, and super powerful. But we also know that there is some cons, like for example, JavaScript is really slow, and we know cases where we'll never select it as a solution, like for example, for heavy computations. Because sometimes we just need more than JavaScript offers, and WebAssembly is a good alternative. It really often outperforms JavaScript while it's able to do the same tasks. So how does WebAssembly work and how you can integrate it with progressive web apps? Well, let's say that you have some app, some parts of your app that you want to implement in another programming language because it will be just more effective for you. You can write it in Rust, C, or C++. And this part of your app you need to compile into WAS module. And on the front-end side, we'll have web app or progressive web app with, for example, service worker and web manifest and so on, and typical features for progressive web apps. And also you have different JavaScript libraries. So you need to add this generated WAS module into your app. And then the last step, we need to send it and execute in a browser. So your browser will execute WAS binaries into a virtual machine. So this is the general scheme, how it works. But there's a more practical solution. This is project called WAS. It's generator for progressive webs and for Rust. It allows you to write the entire app in Rust, but also apply typical features for progressive web apps like web manifest, like service worker, like home screen icons, and so on. And here you can see the official link to this project and also a link to GitHub. I highly recommend you to try this code and try these projects. Let's switch to the last topic, the most common issues based on my performance experiment. What I did, I tested 15 progressive web apps that are in production, and I used measure tool from web.dev platform. And here you can see the overview of my results. Well, that are issues I found. We've counted how many times the issue appeared. And today I will tell you about the top 5 that are the most common, but also I think that are the most easiest to improve in your web apps. And a few words about the tool that I used. So this is Measure from web.dev. It's built on Lighthouse. It allows you to do audit tests, performance tests, and get the overview of your metrics in your web app. It's possible to use for any app that is in production, that is served on a remote server. And it's great because it allows you to get the all advices that will be great for your exactly page. Not general, but for your specific pages where there are some issues. And the most common issue, this is avoid chaining critical requests. Critical request chains are a series of dependent network requests that are necessary for loading your page. And the longer chains and the bigger download sizes, then the impact on the load speed is more significant. And there are some best practices for us to achieve better loading time, that we should minimize the number of critical resources. You can eliminate them, mark them as async, or defer the downloads. We should also optimize the number of critical bytes to reduce the download time, to reduce the round trips. And also you have option to manage the order in which the remaining critical resources are loaded. So at the beginning, we should download all critical assets just to shorten the chain's length path. Tip number 2, keep request counts low and transfer sizes small. And the best option to do that is just analyze requests and resources in your app. You can use the tool that I presented to you before. And another tip is that you can add budget JSON file to your project and set budget limits for specific metrics. For example, you're able to set limit for first meaningful pain, for the overall size of your page, for the total number of requests, and then you're easier to control these metrics in your app. This tip is involved with the main browser's renderer process that typically handle your code and transform it into something that user can interact with. And by default, the main thread of renderer browser's process handle all of your code that is typically involved with parsing HTML and building the DOM, parsing CSS and applying proper styles for your apps, and also parsing, evaluating, and executing JavaScript. And here you can see the impact of different processes for rendering your app, for the time of loading. And as you can see, the most meaningful is script evaluation. And we should focus on delivering smaller JavaScript payloads. And there are some tips how you can achieve that. For example, we're able to implement code splitting. This is a great technique to improve web performance. So we don't want to send the full code to your users. We'll only send the code that your users need at specific time when they use your app. The other technique, this is PRPL pattern. And in this pattern, we'll push all the critical resources at the beginning. Then we render the initial route as soon as possible. Then we will precache all remaining assets. And at the end, we will lazy load remaining routes and non-critical assets. And last tips, we should also minify and compress your code and remove unused code. And maybe it sounds a bit obvious, but this is more practical tip. So if you open Chrome Developer Tools and you add Coverage tab, then you're able to track unused bytes in your app. So you will see resources of your app, and you can exactly check which parts of your code are not unused. So it's really useful for you to find unused parts of your app. Super important, apply lazy loading off-screens for images and for iframes. And now you have option to apply native lazy loading, like at this example, but you can also implement it on your own with intersection observer API and with trigger image loads with JavaScript events. And regarding native lazy loading, let's take a look at the browser support. Well, in general, it works in web Chromium-powered browsers, and so it will work with Chrome, Opera, Edge. Now it's possible also to use it in Firefox for the newest versions. But please keep in mind that it won't work in Safari and Internet Explorer. And there is for mobile browsers, so it's the same situation. It will work for Chromium-powered browsers, especially for Android. So this Android browser, Chrome for Android, Samsung Internet and Firefox for Android. But remember that for other, let's say, less popular browsers, it won't work. So you have to implement it on your own if you support other browsers. I'm telling you about images because here you can see estimated savings for one of tested progressive web apps that I was able to achieve only manipulating images. So with applying lazy loading, I was able to get 18 seconds to save, 18 seconds on load for this page. With properly sized images, I could save 17 seconds. And for applying next generation formats, I could get 14 seconds. So I told you about lazy loading, but other important aspects if we're talking about optimizing and improving web performance with images, this is image size and also image format. And for image sizes, we should never serve images that are larger from the version that will be rendered on user screens. And it's a good technique to add different formats for different devices, like for mobile and desktop. And if we switch to the formats, so apply SVG and also replace complex icons with SVG. And remember about next generation formats like WebP, because this next generation formats has much better quality characteristic and compression if you compare to, for example, PNG or JPG. And there are great tools that allows you to automate the process of converting multiple images into multiple formats. These tools are Gulp Responsive or Responsive Images Generator, and you can easily find them on GitHub and install with npm. And these tools allows you to automate the process of converting and run it just from console. So it's really useful for you, for developer. So let's sum up. Today I told you about the ways how to improve web performance for progressive web apps. I told you that caching is the main source of making your app faster, but it should be reasonable. Please remember about running audit tests before caching. And another tip, consider applying WebAssembly for some cases where JavaScript is not enough good. And the most important, the same performance techniques common for web apps are great for progressive web apps. Because fast web app means fast progressive web app. And that's all from my side. Thanks for having me, for your attention. If you want to get the full slides, there is a link. You can read it after the presentation. And if you have any questions, I am free to answer. Thanks a lot.